Okay, let's start. Thank you
in charge of the camera?
My name is Zbigniew Łukasiak, and this talk will be about
they have to zoom in.
dependency injection. It will be more or less an introduction.
I don't know. I think
So,
you can't see the slides.
there is this big question, what is dependency injection? And basically, it was first, the name was first defined by Mark Fowler in his essay, and it's so complicated essay that basically nobody, there is no one strict definition. Many people just take his essay and everyone comes with something slightly different. So I will not try to define one thing, but maybe give you some intuitions about what is all about. So I will start with some things that are more or less familiar to every programmer, which is configurations. So if you see something like this in your code, then it's an immediate reaction of every programmer that there are magic constants and it's automatic reaction to move this into some kind of config or at least a preamble in the script, like the first lines of the script, where you can find it easily and change it easily. So that, for example, if you change the database or the password, then you don't need to search your sources where it is used, but you just change it in the configuration file. So this is something that is more or less practice of every programmer. But when we look at this, so we move magic constants into configurations. But what if, when creating this database connection, you want to add this additional attribute of the connection, trace error in this case. So if you have it in the traditional config file, where you have just values, just literals, then you cannot put this because it's a hash. It's not a literal. So you need something more complicated. And yeah, so if you put connection creation into config, and then this config becomes a little bit more complicated because you create objects in the configuration file, not just simple values from literal strings or literal numbers. So it's a bit of extension of configuration. So another notion that is somehow related to dependency injection is that you keep all collaborators in attributes, and yeah, you can say that it's basically programming of object-oriented programming. But well, if you look at code like this, then you can say it's object-oriented, but it uses this database get instance. Yeah, so here is this database get instance, and it gets the collaborator, like it's a singleton, basically just a global object that retrieves the instance of the connection. So, and then you have, for example, a login page that uses this user repository to check the password. And here you have a similar case, but instead of using a singleton, it uses a package variable, module variable. So it's also a global. So the next thing here is, well, let's say that we use moose, and so we put this connection into an attribute, and also in the case of the login page, we put this repository as an attribute, and we don't call any new inside of the business logic here. So the idea is that when you need to do something, you have everything that is needed to all ingredients you have on the table, and you just take them and mix them, and you don't go out to a shop and buy the ingredients. The idea is that you have everything ready at the time that you start your work. So, for example, if you have this login page, then you have ready this repository. You don't create it inside the business logic, but you just expect that it is already created. And yeah, so basically at the start you would think that maybe you'd pass this this database connection to the login page, but actually you don't use the database connection directly in this method. So yeah, it's better to pass the repository that you use directly. So you can say that it's more explicit, it's more up front. You declare everything that you need up front, and then you use it. Yeah. So for example, if you use a connection somewhere, you don't retrieve it from a global object, but you pass it there explicitly, either as a parameter or you pass it as a parameter to the creator of the object, so that it is in some of its attributes. So, but this leaves the question, where do you create all the collaborators? Because I say that you don't create them in the business logic. So where do you create? So what is really this extended configuration file that you use for creating all the collaborators? And this is, well, in my opinion, this is really the core of what dependency injection is about. It is that you do all this object creation in one place, and yeah, basically in one place per scope, which we shall talk about scope later. But the idea is that object creation is somehow dirty work, because it's if you want to test it, you need all the classes together. So you cannot extract it somehow, use substitutions for tests. This will be talked at length and at the next talk. So we will have more examples of this. But yeah, so the idea is that object creation is somehow different code from the rest of the business logic, and you will need to frequently change it. So, for example, like doing a configuration in a program. Why do you take out the configuration into configuration files? Because it is frequently changed. You change it more frequently than the logic that is around it. Yeah? And this is the same case with object creation. You change the object more frequently than you change the code that uses those objects. This is, of course, this is not an absolute rule, but it just comes out from practice that it is like this. This is the same with the magic constants. You can have some magic constant in your program that you would never change. It can happen, but the practice is that you move them to configs. So, and And here is something that I don't know if you read the modern Perl blog by Chromatic. So he gave this example recently, and he argumented that you already do dependency injection. So he puts this example of the important thing here is this user agent object. So this is the code before dependency injection, where you create this user agent inside the business logic. And here is Musified, where you have this user agent as an attribute. And I call this a simplified dependency injection because here he just puts the code, the creation code into this default attribute. So for this is the smallest change that you do for a programs to make it substitutable. I mean, if you need something else here, then you can easily create a different object, and you explicitly pass a user agent there. So you can do dependency injection here, but basically because I would argument that because you still keep this new code here, then it's not a classical dependency injection, because you have still this new in the business logic, and your normal programs, they all will use this one. So in Java, I don't know, maybe they don't have this default attributes, so they didn't do it in this way. But I think it is a very good first step for dependency injection. And if you need dependency injection only for making tests, which is the biggest advantage of using dependency injection, is that you can make unit tests, then maybe it is enough, because then in the tests you still can substitute something else into the user agent, but in your code you can forget about this dependency injection thing, and you can just program it like you did before with just this really small change. So you can also say that dependency injection is about avoiding globals, because we cannot substitute a global. So the idea is that if you use a global, then instead you just create an attribute for this global, and in the creator you pass whatever you need to this attribute, and then you use attribute instead of the global. And if you look, if we look at the code, like for example here, you can also say that this LWP user agent, it's a global in the sense that the name of the class is a global here. If you use the dependency injection, then you can use any just any class that is compatible with user agent. So yeah, it's also an analogy to like you remove the magic constants. In this case, this magic constant is the class name. Yes. Yep. So all of this is really yeah, it's not really strictly defined. So it's mostly about values, and the next talk will I hope will give you many more examples of this. So you will have better understanding, feeling of what it is. So why you do this? So the first thing that I talked about is that you can change easily the collaborators, and this is something that happens, that you need to add additional parameter like this raise error to the database connection or some transaction control or something. So so you change the collaborators more frequently than you change the other code. So if you have them in a separate place, then you can easily find it and change it, not searching through all the code where you use it or where you create it. So this is one thing. So it makes your code a bit more flexible. But actually, the biggest advantage is that it makes your code more testable, because for making unit tests, you need to do just this. You need to substitute the collaborators with your mock objects, or maybe some undefined or something else. Basically, test doubles. So that you don't need to create everything, the whole, all so that you can basically create the collaborators easily in your tests, and you don't need to run the whole program to have all the collaborators. Yes. So basically, if you look on unit tests, then it's like making like checking a car part in a laboratory instead of driving the car in on a test loop. So the thing is that if you take out the car part, like a tire, and you put it into a laboratory, you can test. You have much more control about what you are testing. So, for example, if you test if the tire is flexible in under 30, then you can easily do this in a laboratory. But if the tire is on your car, then I don't know, you would have to wait until it is -30 outside to do your tests. Yeah? So that's the idea of unit tests, that you make your own environment where you can test everything more precisely. And to do this, you need to, well, in the case of code, you need to substitute all collaborators with things that you control in the tests, with much more precisely than you can control in the whole program. Okay, so that was the first notion of dependency injection. And then if you hear about dependency injection, nearly always you hear about a dependency injection container. Like in Java you have a few of them, like Juice, Spring, and some other. And in Perl we have breadboard, and I don't know any other. Anyone knows any other? Okay, so I think in Perl there is just one dependency injection container. But actually you don't need to use a container to do your dependency injection. Like like in the code from Chromatic. This is, well, it's like a simplified dependency injection, but it's the first step. You just create an attribute and you put the creation code, the object creation code into the default parameter of the attribute. And yeah, it's the first simplified dependency injection. You can do it like this. Or you can do it with factories. Or, well, I also have, it will be on the links on the last slide. I also have translated do-it-yourself dependency injection talk by some guy from Java. So I have translated the Java code into Perl, so if you would like to have a view how this is done, and yeah, it's rather unintuitive. I still didn't fully digested the talk by this guy, even though I did the translation of the code. So maybe I will talk about this next time. So, but the point is that you don't need dependency injection container, dependency injection library to do dependency injection. Because at the core, it's simply about moving out all the object creation outside of your business logic. Yeah, so I don't know. So I have a few extensions to this, because that was mostly the definition of dependency injection that we covered, and then we have some related notions. So one is normables and injectables. The idea is that with some objects you don't need to inject them, because the creation of those objects is so easy that you can create them in test instead of using mockups. So one example of this would be, I don't know, big int. So the idea is that if you use a big int in your code, then you just new it. You just create this big int. Because it's so simple, simple value. Or another example might be date time object. So you just create it. But on the other hand, if this date time is, for example, the starting date of something, then you would move the code anyway because into a config, because a start date is always it's something that changes frequently, so you would move it outside anyway. But there are cases like this that basically you can leave it in your business logic code. And if you analyze it more thoroughly, then well, this is something that I copied from one of the Google gurus that writes about dependency injection. But in my opinion, the separation between those two is very fuzzy, and for me it looks like most of things are injectables. So renewables are really the simple objects. And there is also this thing that if you can't create objects without parameters, then it can be renewable. But if there is a parameter, then it is mostly injectable. Yeah, so the container libraries, what do they do? So So anyway, if you have class A that uses class B, that uses class C, and let's say and D, then you have a tree of objects. And if all of them, let's say all of them have parameterless creators, so you can create this tree without any parameters. So the thing is that if you need A, then creating A is pretty much automatic, because a program can just scan the tree and just create all the nodes in the tree. So if you tell the program that you need A, it will know what needs to be done. So creation in this case is very simple, and this is what the container can do for you, so that you don't really need to create this whole tree. It is done by the container. It solves the tree. It finds out what needs to be created if you need A. So that's what the library can do. And in Perl, this is Dreadbot. So the question is how many places with how many containers, factories you need in your program. How many places you need where you create the objects. Because we say that in the business logic you don't create objects, so where do you create? So at the start you just think that maybe it's just one place where you create everything, but this is not always possible. Because, for example, if you have a program like a web server, then the object of request you cannot create at the start of the program. You need to wait until the data from the user comes to the server, and only at this point of time you can create the request. And then if something depends on the request, then with this other object you also need to wait until this time. So, for example, in a web server, you would have two places where you create objects. The first is at the program startup, at the application startup, where you create everything that can be treated this time. And then when the request comes from the user, then you can create all the objects that need the request. So in this case you have two scopes. But I haven't worked with any dependency injection framework, but I've heard that some frameworks have something to do with the scope, so that you can declare you have just one container and you declare the scopes inside the container. So you don't need to have many places in the program. You have just one container but with many scopes. But if the container doesn't support scopes, then you need many containers, because then the container is a simple factor. And the last thing is the law of Demeter. How does it relate to dependency injection? So if I say that dependency injection is about having everything ready for your computation, so that you, at the time that you do something, you have all the ingredients ready. So the law of Demeter, maybe it's not the orthodox definition of it, but the idea is that you don't have more than you need. So you don't pass anything more, then it's directly used by your code. And it is related to dependency injection because you could cheat by passing an object that has everything. Yeah? So you could call it environment or something and pass it everywhere, and then you are okay with dependency injection, but it's somehow cheating. Yes. Is that understood? If dependency injection says that that you don't use globals, but if you pass, you can just pass an object that is everywhere the same. You know, just pass one object. You call it environment, and and you can have all the globals inside the environment. Yes? And since you pass it everywhere, it is available everywhere, and it's basically a global. So you can cheat. Okay, so questions?
In the first part, you were talking about the object-oriented config. Have you brought a practical example of that to look at?
No, but there will be more examples at the next time. Yes?
My question is more towards, you started with configuration files for just variables or connection strings or anything like that. So, but later on you targeted more towards testing, so you actually break out declarations of objects or classes. What happens, or how does this concept goes into line when there are more than one programming languages are used?
Oh, I didn't think about this.
Because, I mean, you have projects where, for example, database connection strings are used from 3, 4, 5 different languages. And, I mean, if you start to make it more language specific, you actually can't break this part out.
Yeah, in practice, I think you will need 2 levels of configuration, actually. The first level would be, language independent, just like, I don't know, ini5. And then you would have language dependent object oriented. Basically, it was more an analogy because the object oriented config that I am talking about, it usually becomes very complex. It's not something so simple like a simple config. So it's something that you still need to be a programmer to understand it and edit it. Okay. Another question? Okay, so here are some links, and this Miško Herrera is I think the best explainer of this subject. So most of what I know I discovered from his talks. So yeah, he's from Google. And then this last wing, this black sheep paralog, this is this do-it-yourself dependency injection. And yeah, I didn't put the link here, but I have translated his Java code into Perl if you want to have a look. This is available at GitHub. Okay. Thank you.
I think we can do a 10 minutes break. Then just come back.
Tak jest.
Yeah, it's just got, yeah. It's mainly got. If only I can make the thing work. It's a simple application. It's very simple. Like, the thing is like sampling the output processing, producing some input, and having different sorts of input and different ways of generating output. Yeah. Sorry. Yeah, that's also an example of heaven data. The actual